Allergies. It's not fun. Alright, looks like we're streaming. So I'm going to go ahead and reload this page and then tell everybody that we're streaming. Streaming game dev. Gonna work on squiddy things. That's not the right link. That's the right link. What have we got here? Yeah, there it is. Just triple check here. Okay, looks like the audio is fine. And there's no weird audio in the background this time, because I actually turned off my various fan-like things. How exciting. Alright, so last time I abandoned work on the squid tentacle because I couldn't figure out how to get the suckers to work without a million bones. So I decided to try a couple of different solutions today, and that means we're going to be doing some testing. Everybody loves testing, right? So we're going to create some one-off models that we're going to need in order for testing to work. And that's going to start by creating just the base model that we've been using. We're going to be using an adapted version of that just to start with. So that would be this guy. Basically, we want these to be considerably more protruded than they currently are. I made them quite fat, and that wasn't really what I should have done. So we got a couple of options as to how to do it. And I think the real answer is we're going to just start over, create a new one. And so for now, we'll just move these things aside. And we'll mark this as an arm. Now, we're not going to be using a separate sucker model or a separate sucker material. It's all going to be the same thing in this one. But the basic idea here is that these suckers are going to have to be more protruding than they were before. Because when I did it that time, they were very close to the baseline, which isn't really what I wanted. So we're going to just create... Come on. Okay, whatever. There we are. We're going to create just a test kit that's going to be substantially more protruded, and we're not going to worry too much about like linking it into the overall shape of a tentacle just yet. We're going to work on that after we know whether it's going to work or not, because there's no reason to push ourselves. If it's not going to work, we don't want to waste a whole bunch of time. And we're going to probably go ahead and just cut this in 4 for now. There's no reason to... do we want to do it? Let's cut it in half for now. We'll cut it in 4 later. So there are a couple of different kinds of... let's just go ahead and pull up some references here. Octopus tentacle. Octopus sucker. So the most commonly shown one is in, game fiction is... I don't know what the technical term is the red octopus, the one that you see when you're making octopus meals. And the way that those are laid out, the way those suckers are laid out, is in alternating sets, like I had with the other set, with the other setup. I'm not sure whether all octopuses are set up like that. Some of these look considerably more random or even side by side, but I think that is the most common setup. See, there's like some smaller octopuses, I believe they're the smaller ones anyway, have these really, really long protuberances. And even the red octopus suckers are more protruded than I gave them credit for. And that's because they have to move around. They're basically fingers. So we're going to go ahead and cut this into pieces for a minute here, because it will be easier for us to paint once it's in pieces. Oh, I deleted it? How did I delete it? So we're going to use mirroring to create the final mesh, but for now what we're going to want to do is paint it. So to do the painting, we're just going to go over into paint mode here. Weight paint. No, that's just weight paint. I want vertex paint mode. So we're going to be using a base of black this time because it's easier to kind of conceive of a black base. Using a white base is just as logically useful, but it's hard to keep track of what colors you're using when you're doing subtractive math in your head. So we're going to be using black this time, and we'll do additive math instead. There must be like a quick fill method, but I never found one. All right, so we got a couple of things we're going to need. We're going to need to have the whole stretch area. So if this is our thing that moves, if this is our finger, we want to have what basically amounts to a joint. And we're going to be using red for that. So let's go into, well, actually, we're technically already using red for something else. We could change that, but let's use green for this. So if we come over here, we can just set this up as green. And basically, we just want to use green 100% over here. And we'll be painting a different color down there, so we're not going to worry about that too much. And then we're going to be just lowering the quality of the green as we move back. Yeah, that ought to give us a nice smooth fall off. Now for the front, we're going to be using two colors because we need to make sure that the sucker part is its own sucker. And that's actually something that's not working right now because I didn't shape it right. Let me just take one more look here. Yeah, so they actually exist as their own thing. The images I got that look like this is a retracted setup. It's a retracted sucker. Which we don't want. We actually want the opposite of that. So we're going to go ahead and create just some density to it. Like that. We're also going to make sure that the whole thing is smooth. We do not need the auto smooth normals, but you can see how we've got this crease here. Auto smooth normals are turned off. There should be no creases. I'm not sure why we've got a crease. I'm going to hope that that's just an illusion. So anyway, what we're going to want to do is use red and blue. Blue. We're going to use green and blue here. Now the green is still necessary because we're using that to track the target. We could like switch off and like do max of both. It makes more sense to just do two different colors at the same time. And so the blue is going to be how much radial motion there is, how much it will try and grab. So we're going to just go ahead and paint that in all the way out to this edge. And you can see that we've got another edge that's very, very close, this one here. We're going to go ahead and lower the amount of blue so that we don't have a 100% just sudden cutoff here. We want to be able to sort of move in, but it still has to be 100% green. And lower the pixel size so we can actually hit it. Now, if your eyes aren't very good, like mine aren't, we're kind of relying on the math here because I can barely see the difference in these colors. So I can't really even tell whether or not I'm actually painting them. I think I am though. And then we're going to want to drop it down one more notch, down to almost 0. Why do you keep selecting it when I'm trying to drag it? There we are. And that'll be this one here. And again, I cannot actually see if we're changing the color there because the blue is such a faint setup, but I believe we are. That's good enough. So now let's turn on the mirror. And I don't see any obvious problems. There is some bleed over here. I think I was a little bit irregular on some of those edges. That's fine, we can deal with it later. So we're gonna just call this sucker. Sucker. So the idea here is that we're gonna test out some basic functionality and see whether or not we can get this sucker to follow around some... Well, that's friggin' weird. Dear heck. Is this whole thing inside out? No? What is this? Well, let's see what it looks like in... Sorry, there's stuff making noise down here. My recycling was settling funny. So let's go see what it looks like in Unity here. And then, you know, we'll get a couple of ideas out of it. So we're going to want to add in just a new cube, create a cube, and this will become our sucker. There it is, exciting stuff, right? So we don't need a collider. What we do need is a new shader because we're going to be using some techniques that are a little bit more complicated. I'm not 100% sure I remember how to do these. So we're going to have some fun trying to figure it out. So if we look down here under fauna, we've already got something called octopus. We're going to create a new shader that's very similar. We're going to call it suckers. And this will just be applied to anything that's got suckers on it. All right. So one of the core pieces to our suckers are that we're taking in some 3D, 4D, taking in some 4D verts as arguments. So what we really need to have is an array like this. So the only problem with these global arrays, well, there's a lot of problems with them. One of the problems is I don't believe that you can change their size on the fly. At least the last time I tried, I couldn't get them to work. And we're going to go ahead and give it vector 4s here. And that's going to be, I can't remember whether it's object or, well, we'll find out. So this is going to be attractors. There we are. So the idea here is that we now have a global array, but the problem is how do we ask the global array whether or not, you know, verts are nearby? And to do that, what we're going to need to do is take a delta between all of the global array elements and the verts and figure out which one is closest and how far away it is and all that jazz. So to do that, we are going to get a closest vert out of this. And unfortunately, that requires some custom code. So the custom code here has a couple of values that it needs to take in. The thing to remember is that this isn't actually generated unless it's linked properly from front to back. So the custom expression will generally take one of these bad boys in specifically just to make it so that you can access it, but the name of the variable we use to take it in is completely irrelevant. So let's go ahead and just take a look here. It's going to be in. We're going to call this a vector 3. There it is. And we're going to call this vertex. And then we're going to need another one, which can be anything we want. We'll just call it placeholder. I made these global attractors. Oh, that's fine. We'll leave them. I wasn't sure whether to leave them as vector 3s or make them into vector 4s. If we make them vector 4s, we can give them a radius, but that might make it complicated to actually do the math. That's fine. We're going to leave it like that anyway. The other thing we're going to need is the vertex position. There it is. Now, the only issue here is I don't remember whether this is global or not. It's in object space. There's got to be a global position, right? World position. There it is. We'll use world position. I want to delete you. Thank you. So with that in mind, we have these two values, and we're giving an output. The output's going to be a float 4, not a whatever it was before. And we need to make this custom expression have some code in it. So we should be able to go through all of the global array, which is called attractors with a capital A. And we should be able to work through all of it. So for int a equals 0, a is less than attractors with a capital A. It might be an underscore situation. I can't remember. I can't remember whether this is a capital L. I think it is. Vector 4. Is it vector 4? I think it's vector 4. Best. Bool. I'm going to say best equals attractors 0. And then we'll just start here at 1. And basically all we're going to do is we're going to say that if the length between the best value is, you know what, it makes more sense if it's a vector 3. It's just gonna be annoying to do all the math if it's a vector 4. We don't have a vector 3 option. We've only got vector 4 options. Okie dokie, never mind. So basically we're needing to take the delta, so we'll just go ahead and say distance equals best, what is it, vector 3 dot range or dot distance, best, and what I call it, vertex. Float d1 equals vector 3. Now this is not optimized, but I don't care at this point. We'll optimize it later if we need to. I'll go ahead and optimize it now. So just so d1 equals, that's right, let me say if d1 is less than delta, then we simply set delta equal to d1 and then set best equal to attractors A. And then we return, I believe we return best. We might need to set something equal to best. I can't remember. Either way, once we've got a value out of this, what we're going to want to do is set it up so we can see it. So we have a couple of options. For now, I think the best option here is instead of outputting a float 4, let's output an int. Just because that way we'll be able to tell what is closest. So we'll go back to returning best afterwards. But for now, it makes sense if we have an int, and then what we can do is we can set the color based on the int. So for that, we're going to do a remap. And it goes from 0 to 5 down to 0 to 1. Just set that as the albedo and hit save. So now that we have something like that, you can see that we've got some errors here. It's not a big deal. It just means that we spelled something wrong. Unexpected identifier best. Expected, comma, or... No, that's... Do I have to define them as being a specific scale, like protected? I don't think so. Okay, so I have to actually just quickly look this up because I don't remember how it works, and clearly I've spelled something wrong somewhere. It's one of those things where it's super persnickety. So we're just going to go ahead and look up what was the shader we're using? It's amplify. So we'll just look up amplify array, custom array, global array. What was it called? I think it was called a global array. Global array. Well, it's taking 45 minutes to open, so we'll just keep moving down. All right, so I'm looking at something on the other screen, so it's a little bit hard for me to see it here. This is someone trying to learn how to use it. Where is the sample that actually works? Well, there is a sample that actually works, but they're not showing it. They give us a download, which I happen to have. I already looked this answer up. But I don't know why they don't just show the code in the frigging... I don't want to have to open up someone else's project just to see how they did it. Maybe I'll just have to look up Amplify Shader custom node. What was it? Custom expression. Let's try that. Well, I mean, their setup doesn't appear to have anything special about it. I don't know why mine would break and theirs would work fine. Well, let me take another look. Maybe I'll think of something if I... oh, that's the wrong window. That's the right window. All right, so my custom expression, currently we're getting a vector 4 error. And that might be that the vector 4 is something that doesn't exist. Let's go ahead and move the index to the top and see whether that gives us an error. I don't think it understands the concept of a vector 4. Does it use a float 4? I mean, they're the same thing. I guess technically a vector 4 could be like a double vector. Maybe it's a lowercase v vector 4? Let's find out. No, I'm pretty sure it's still bugging. So, yeah, so we'll have to figure out, is it a float 4? I bet it's just a float 4. Yeah, so it's just that there's no such thing as a vector in this. It's all floats. We'll try it. The only issue is I'm not sure. Line 29. 29. It's not. There's no lines. There's no line numbers listed. I think that is the last line. No? Is there a float 3 dot distance? That's the only thing, is I'm not sure if there is a float 3 dot distance. I don't think there is. Amplify shader custom expression distance. Missing distance. Well, obviously it's supposed to include distance, you idiot. Um, I might have to open up that example one more time. I don't want to, but I guess I have to. All right, give me a second. I gotta send you back to Phoenix Wright for a second while I import that particular shader and see what's up. So we'll just create a new folder. We'll call it test crap. We'll put the folder in vaguely the right place, and then we'll tell it to import a new asset from, I believe this is the correct directory. Amplify, post-processing, scenes, test folder. Amplify, shader, test. Global array, for loop. A for loop? No, this is the wrong way to do it. I think I got the wrong one. Give me a second. Just amplify the other one. Global array, distance check. And we'll just copy. Oh, it's just distance. There's no float 3 or anything. That's easy enough. So I'll bring it back. We'll go ahead and look at it. So we'll go back up to flora or fauna, wherever I put that. Suckers, pop that up. Oh, oh, it was still loaded. Okay, I didn't realize Amplify actually kept things up in different tabs. That's cool. So there's no float 3 dot. It's just distance. The problem is there's not really a good reference sheet for this stuff that I could find. So it's like there's no autocomplete. There's no reference sheet. I don't know how you would figure it out. The only thing now is I'm not sure whether attractors actually exists. It might be underscore attractors or something like that. So there are some errors in most of these, but these are integers that are, that's not an issue. That's like the debug output, so I'm not terribly worried. If we take a look and we drop in the suckers, is the suckers like its own? Yeah, we're going to go ahead and delete that suckers and create a new suckers. And you can see that it's pitch black. That would mean a 0. Since all of the vectors are in the same place, that 0 makes plenty of sense. What we would really like to be able to do is to edit the materials here, but I don't believe we can. How nice is that, right? I believe that the way this works is I have to set them in real time. Unless I need to set it up as like auto register. I'm not sure. No? No, I think I have to set it up manually, which is one of the reasons I don't generally try and do this on screen. But fundamentally, the issue here is simply I got to make something that can set those values. So we're going to go ahead and inside of this cube, we'll create an empty object, and then we'll put the cube inside the empty object. And we'll put the cube at 0, 0, 0. So now what we're going to do is put a new helper function here that's just going to set those values. So obs came in to say what's up, CDog. I am testing out some complicated stuff, and I'm not sure whether it's going to work. I guess I should probably use like a debug or a test folder here. That's not how you spell test. All right, there we are. So once we go inside test, we should be able to create a script, which we're going to call the quick position setter, quick pause setter. We'll call it the quick shader pauser. Quick shader pause, that's fine. In 15 or 20 minutes, when that compiles, hello. Yeah, that's nice. Drop it on. Obviously, it doesn't do anything, so it's going to take another 20 minutes for the IDE to boot. So I guess I'll just take a quick little look and see whether or not I've gotten any messages. I have not. Ooh, I'm slouching down in my chair. Too much time. All right, so here we are in this quick shader pause. We're going to want to point to a material, and then we're going to also need a name for it. And I believe we called it array position array or array position, or this is the reason why it's annoying when you can't see it here. Global array attractors. We just called it attractors. Okay. It's probably underscore attractors. We'll know soon enough. So here in start, what we're going to do is we're going to create a material property block. And then what we're going to do is we're going to set the array, set vector array, here it is. And basically when we set the vector array, we're supposed to pass it a list or an array of vector 4s, which is fine. So that's what we'll do. Why is that red? Shouldn't that be fine? You can't resolve that symbol, huh? Yeah, well, screw you. You'll resolve it someday. For int a equals 0, a is less than max ling, a plus plus. Oh, it's lowercase l. That's the problem. And then we just say vec a equals random dot on unit sphere. I'll give it a size here. There we go. And that should do it. That should give us a bunch of random bits. And then down here to draw it, we will go ahead and use a void on gizmos, on draw gizmos selected. Thank you. We'll say if application.playing return. Otherwise, we'll go ahead and do that display. So why is this still underscored? Yeah, too many different languages with their own rules here. Otherwise, we'll just go through it. For each vector 4 or vector 3, it's a vector 4. Pause in, oh, we didn't actually keep it, did we? We also need to set a z value. Oh, we'll do that later. For now, it should be fine with a z of 0. And then all we have to do is display it. so we're just going to say gizmos.drawWire sphere pause. I think we have to cast it manually. Not a vectro. All right, there we are. So I think that'll work. So let's go back over here into, well, let's go ahead and make this something where, let's just polish this so I can do it in non-play mode. So we're going to go ahead and put this in its own. Now we forgot a couple of small details. One of those details is that we need to make this a menu item. And the other is we actually have to set the MPB at some point. Just creating it and then not doing anything with it is not terribly helpful. But it's not a material, it's a mesh renderer. I don't think we have to worry about the material index. I think it's just going to be one material. So we're going to go ahead and give it a shot here. Just pop back over into Unity for a minute, if I can get Unity to pop up. Quick shader pause.override is fine. Are you fucking happy now? I didn't know override was reserved. So in theory, this will work. So we're going to go ahead and tell it right now to go. It didn't work. It didn't. Is it not? There's too many different options now. It used to be that there was only one thing that would pop up. And now it seems like I can never remember which of the 85 options does which thing, because they're all named the same shit. It's just like, you have any options here? Look at, why isn't it showing up? I'm not... Clearly menu item is the wrong thing. It needs to be something else. Is it context menu? Yeah, there it is. My bet is that it's that was the problem, and override is fine. Let's find out. I don't want to have to stop using the word override if I never have to. Yeah, that's fine. So if we then override it, boom, you can see how we've got a bunch of little teeny pieces, but we never assigned our shader. So let's do that. Let's do that. And then override again. Boom. All right. So in theory, boom. In theory, this thing should change colors, but it is not changing colors. Now, the reason for that is probably that I have the wrong name. So we'll just try some variants and see if we can come up with something that works. No, there's something. All right, well, give me a second. What I'm going to do, well, I guess I'll just take a quick little look at the temporary test things we were looking at here. This is the one. This is not the one. So we'll just delete that one. It's just barfing up errors. This is the one that has the various values in it. Distance check, positions array, I don't see any issues with how we're doing it as compared to how he's doing it. It's the same thing. But I didn't import the script. So I guess what I'll do is put you on pause for a second. I'll import that script so that we can just see how he did it. Because it's one of those things where, for some reason, it's super hard to figure out, at least for me. And there's no tutorials about it or anything like that. You'd think they would just do it. All right, bring you back in here. So here's the amplify script that they're using. And you can see how he's setting the vector array positions array. So he's not using an underscore or anything like that. And he's not using anything particularly special about the positions array. I mean, he does have range check selected. I guess, technically speaking, there could be a problem with... That looked like it was almost about to work. Yeah, the problem is I don't actually know whether the error is in this or in the shader, because I can't friggin' tell. Super Donut says, Monk of Time says it's just complaining it's not a static function. Yeah, sorry, Monk of Time. That was I was looking at something else on that screen and didn't see it. Super Donut says, how you doing today? I'm really hungry, so I'll probably only get another half hour in before I am forced to stop and eat. But I don't know right now. What our problem is that we don't know whether or not this global array is being modified or not, because I don't know for sure whether this is valid. So we're going to create a new custom expression. And we're just going to do the same basic thing, but it's going to be a little bit more complicated. So the inputs are going to be float 4s, like so. Yeah, that should be fine. It shouldn't actually matter, is the thing. And then we're going to output a float 4, I guess. And then what we'll do is we'll just add up all of the values, and we'll see whether or not it works. So yeah. The idea here is that I'll be using these to derive the squid tentacles. At least that's the theory. So I have to get it to work. I think that it's length. It might be... No, I think it's magnitude. But I don't remember exactly. We'll have to find out. It'll barf if it's wrong. Actually, it won't barf because it's not... it's not actually part of the chain, so it's not compiling. So we're going to want to make it part of the chain. Okay. That's weird. Okay, so what we're seeing here is that we have a different set of values at the front and at the back. It's actually showing the vertex colors. I see, there's an error. So it's just defaulting the vertex positions. Unexpected identifier total. Float total equals 0. Why do I have to say it's a float 1? That doesn't make any sense. Oh, it needs to have a float return. Invalid subscript magnitude. Is it magnitude instead of magnitude? Let's find out. No? Is it length? How the fuck do I get the float for scale? Let's just use the first value. Attractors A dot. Is it going to be X, do you think, or is it going to be a subscript 0? Okay. The variable target of quick shader pause has not been assigned. That was a long time ago. Okay, so here is the theoretically working version. Right now everything is at 0. It should become very, very bright. No, it didn't. I don't really get what's going on. I had this problem last time as well. I tried it before, but I got it to work last time. So in theory, what happens if we just say return 1? Okay, so that works. It may very well be that excuse me while I sniffle. It may very well be that it's not correctly setting them, and that's just the problem here. Okay, let's take a look here. We never actually opened their Amplify test script. Let's give it a shot. Let's open it up. So this is the same basic setup that we're using now, except for they're using some objects. We'll be using objects as well. I just didn't want to muddy things just now. And here they're using a material property block. I believe that's what it is. Yeah. They're setting the vector array equal to some vector positions, just like we are. It's almost identical. So here's where we do it. We're calling our material property block MPB because there's a block in it. Array name vector, and the array name is attractors. And the array name is attractors. I suppose we could try to manually type it in. Maybe there's something strange about using a variable for it, like there's some kind of white space necessity or something weird going on. Let's find out. Nope. And vec is a vector 4. They're also using a vector 4, same way. Now, the difference is that they're manually specifying it with a vector 4. We're using a vector 3, which I believed would automatically cast to a vector 4. We'll go ahead and manually cast it and see whether or not that is the issue. Hobbs likes the name Craig. I don't. Every other Craig I've ever met has been kind of a douche. Okay, so I don't know why this isn't working. Let me mute you for a second. I've got to go ahead and blow my nose. All right, I'm back. My nose is a little bit clearer. Let's go ahead and do a little bit of something to make it so that we can see what's going on in there. There is actually something called a debug value. I just don't know what it is. You can see there's this debug. I don't really know what that is. And it doesn't really pop up anything. Let's go ahead and take a look at debug. Debug switch. The debug switch outputs one of its inputs according to the currently selected option. Oh, that's the debug switch. I actually want the debug, like, thing on the suckers. Come on. Let me select it. Just... there. Fuck you. Thank you. Assholes. There really should be a pop-up. There should be a tooltip. It shouldn't require me to try and hunt it down. The debug input generates a preview shader that overrides all other active inputs, the drawing only what is plugged into its input port. Okay, I don't actually know. I think that's basically what I'm doing now. There's no reason for me to change it up at all. All right. So, there are some other things I wanted to try, one of which is I want it to have a glow color. And the reason for that is, that's a vector 4. I need a color. There it is. And the reason for that is I want to set the color and see whether or not we're getting any sort of actual override here. Maybe the problem is that we're not overriding at all. So color takes an RGB value, and so we'll just use a random.value, random.value, random.value. That should work. All right, so now when I tell this to go, it should glow. It is not glowing. That's interesting. Well, let's override the glow value. Glow, set to green. See that? Wait, if it's set to green, why can't I fucking see it? So it is actually working, but for some reason none of the visuals are changing. That's weird. Why is that a thing? Okay, why didn't that... Okay, so it's now deleted my mouse. Fuck you. So there's something wrong with this. It's not actually displaying the override values. See, glow is just going straight into emission. There shouldn't be any... Yeah, so when I override it and tell it to be a different color, it should override and be a different color. And instead it turns black. Why is it always green? I mean, it should be 3 random values, but this is like... Well, I guess it is 3 random values. It's just very green. So I'm trying to figure out why it isn't glowing. That's super weird. The only thing I can think of is that the material property block might actually be breaking. So we're going to go ahead and try again. I've just commented out the part that actually does the work. Okay, so setting the setting the vector array actually breaks it. That is very strange. Okay, so what I just did is I decoupled. Super Donut says, are you ever going to go for affiliate on Twitch? I mean, I qualify. I've been on Twitch for a really long time. I just haven't been doing anything. They sent me a couple of emails. I don't know whether I qualify for affiliate. There's a whole bunch of names. I never bothered to keep track of which is which. But as you can see, I'm not really very good at Twitch. So that doesn't really make any sense to attempt to monetize it. I do it mostly to try and stay focused, but what I just did here is I detached the custom expression, which meant that it stopped compiling, and then it worked. However, maybe the problem is simply that the output is not compatible with the albedo. Let's try it. Let's do a lerp from black. So all right, so now if we come back down here, that actually looks like it fixed it. So it looks like the actual problem was simply that we were taking in a float as the albedo, which I assumed it would just cast as either red or as gray. It did not. So what we've got here is the game object is currently maxing out at 5, and that's correct. So we're going to just switch that back to the... no, that's not it. There we are. Switch that back to the actual calculation. There we go. Now, this calculation should give us an albedo between white and black, depending on which of these values it's closest to. However, it appears to just be giving us white. I don't see any signs of it going for black. Well, let's change the lerp white to. Let's give it a second color value. We were using glow before. Let's put that glow back in. Yeah, that'll do. Because the emission is obviously going to be a problem here. But the thing is that if we're lerping white to, what I really want to do is lerp black to. We'll just do a lerp, just a plain old lerp. There's no need to lerp to or from anything here. We'll just manually plug in that. And we'll specify white and black. Okay, it does need to have a color. That's annoying. Okay. So we'll call this tint. Yeah, more or less. So I'm thinking what's happening now is that it is calculating, but what's happening is it is casting an integer incorrectly because I am outputting an integer. I guess we'll tell it to output a float. Okay, that's better. Yeah, so it was in fact the problem that we were just having an integer. And as you can see, we get this kind of Voronoi effect as we move around. See that? That's the pieces that it's closest to. These little white glowing balls. Those are the things that it's close to. And what we're going to do is just polish this for a little bit longer. Shouldn't have taken this long in the first place. Sorry about that. It's just one of those things where I did not expect it to take this long. But every time I do this, it takes this long. There's just something about it where I always do something wrong, and then I go looking for bugs in places where there are no bugs, and miss the parts where there are bugs. That's the nature of the game, I guess. So what we're going to do here is we're going to need to have a, going to have a list of attractors. Moreover, we're going to have to do one more thing here with the actual material. If at some point you let me click on shit. So there is this array length that we can take in. So we're going to want to allow ourselves to have that array length. And we'll set that to a default of 5. So that should work. And then over here on the remap, there we go. That should do it. And the thing is that I don't know whether we can change this in play mode as effectively as I would like. I have a feeling it doesn't actually work. We'll find out. So that broke. I don't want to open it there. What? Wait, it works now? What? What's going on? Why did it? Whatever. So basically we need to have a list of objects. Public transform attractors. And then what we'll do is instead of having a max len or any of that, we're just going to go ahead and use the attractors. So over here, what we're going to want to do is say int max len equals attractors dot length. Good enough. And then when we come down here, we're going to say mpb dot set int, and that's going to be num array name. Is that correct? I think that's correct. And then we give them a max len. That should work. The only problem is we're missing things like scale and stuff like that. So this is obviously no longer an issue. We're going to be using the position. So vector3 pos equals attractors a dot position. And then that's actually going to be a vector 4. Not a vector 5. And then we're going to say pos dot z equals, no, pos dot w equals the scale of the attractor. There, should do it. Now, the only other issue we've got here is that we are currently taking the distance between two vector 3s, but it's actually between a vector 3 and a vector 4. So that means it's probably going to cast to vector 4s, and the vector 3 is always going to count as W0. So we're going to end up with the larger scale objects being further away. We're going to have to deal with that. We're going to have to rewrite the code a little bit. It's not a big deal, though. For now, we'll just leave it like this. As long as it's not randomized, it should be fine. So here in the game object, we need to have some attractors. So we're going to go ahead and create some. Create empty. We're going to go ahead and just call this A1. And then we'll just, that's so stupid. The way that it auto lists these things is just the dumbest. There we Let's go ahead and change it to 6 and see whether or not it barfs. So now that we've got that set up, we should be able to tell it to, oh, these are all empty, aren't they? You know what? We should add in, let's go ahead and just add in let's replace them with spheres. So let's just mark these as colliders here. Let's just remove them. And let's make, there we are. Same thing as before, just set them up. They're spheres, thank you. So now that we've got a whole bunch of spheres, we should just move them around so they're not in the same place. Boom. And you can see that we can't see any of those little circles. They're actually there, but now they're inside of these objects, which is really the way we want to do it. So, well, obviously this is something where we'd have to update them every frame and all that jazz. As we move this around, though, you can see that it gets to respond differently to different attractors. And this is the basic idea. Now, in the actual version, the attractors are going to be far enough away that the object is never going to... Ooh, that's not what I want. The sucker is never going to be close enough to do this kind of Voronoi noise situation. It's going to be entirely within one of their ranges. But for now, we can simply get rid of most of these spheres. Now, see, I don't like what I'm seeing here. What I'm seeing... Well, no, I guess this is correct because I didn't offset it by 1. Okay, that's fine. So, I think that it is good enough for now. What we're going to want to do is actually start to set up the vertex offsets. How much fun is that going to be? I don't know. Let's find out. Someday my clicks will work. There we are. Don't think we need tint anymore. We'll go ahead and leave it there for now, though. Basically, we're going to be using local vertex offsets to move the squid tentacle elements around. There are a couple of elements that we're going to need for that. So the first thing we have to realize is that my custom expression is currently outputting an index, and it doesn't want to. It shouldn't. It should be outputting a float 4. So let's get that float 4 working. And that just means we're going to be deleting index values and returning best. Later on, we'll go in and cast the delta to, cast the attractors to a vector 3 before doing the distance calculation. I mean, I guess we should probably do that now. Oh, vertex is already a float 3. So I don't know whether or not that's going to work. Let's save it and see whether or not it barfs. Divide by 0. I'm not dividing by anything. The only place I'm dividing is... Oh, wait. What happened to the... Am I high? I know that I put in... Okay, so the global array, the array length doesn't appear to be taking any... it must have undid itself. Let's go ahead and fix it up, see whether or not we can get that to work. That would explain why it suddenly started working again. It reverted back to an earlier save. I didn't tell it to. So we'll go ahead and set that up as just a default of, say, 5. Now you can see it's barfing. So you can't actually use this array length. It just doesn't let you set the array. It's array dimensions must be a literal scalar expression. So why is it an input if you can't set it? Yeah, it doesn't matter. I can't set it. So that means that we're going to be using, David Goder says, is he late? Yeah, I'm actually almost done for the day. So you're quite late. But since we can't set the array length, we're going to have to choose an array length and just stick to it. For now, we're going to go ahead and assume that it's just going to be 5. I don't think it'll matter right now because if we set less... Does that work? Let me see. Let me see if it works. Why are all of these leaves open? Whatever. I think if we set it at less than 5... no, it barfed. Okay, so that means that we do have to have a value here. This is annoying because it's just a limitation that shouldn't exist. So we'll just add in the others and have a list of 5. Cancel. There. Because 5 is what it's currently set to for length. So in theory, this will work. No, it's broken. Why did it break all of a sudden? So I changed something, and then I changed it back. And now it's broken. Oh. I'm remapping. I don't want to remap anymore. Of course not, idiot. Hello? Delete. Fucking delete. Okay, I don't know what the heck was up with that. So, the challenge here is that, yeah, the challenge here is simply that I don't have a value set up for it yet. There's no way for me to get the visuals on it yet. So we're going to get the visuals on it over time. Right now we are getting a vector 4 out the back of this thing. And so what we're going to do is we're going to calculate a bunch of values based on that. So some of the values we're going to have to calculate are what the heck that vector 3 is. So we're going to go ahead and assign a value. And we are going to call this the closest. The only problem is that that is a vector 4. So what we actually need to do is to break it and then reassemble it. So we'll do that. Break into components and then assemble it and back into components again with a vector 3 as our target. I'm not aware of any easy way to cast it as a vector 3. That should be fine though. So that's the closest point, as you see. So we're going to be using that in a lot of calculations. We're also going to need to get the distance, and we may as well store the distance rather than calculating it out over and over and over. So if we then just grab this world position and do a subtract, we can get the distance. So distance... There we are. And then we can register that as well. And that'll give us 2 of the values that we're absolutely going to need. And those are basically the only 2 values that we need right now. So we're going to comment that, and we're going to say find closest point. Now that we have the distance here, we can just get the distance and use that as our lerp. Excuse me, as our lerp here. So if we're going to lerp between, I don't know, that and white, all we need to do is get the local variable for distance. And that means that it's going to get to be just blindingly white whenever we're more than a meter away, which is fine for now. We're just testing it. Do you have any plans to actually load this? Thank you. So if we now reload this, pow. It is just plain old white all the time, no matter how close we get. That's not right. That's strange. That shouldn't be the case. Is it not outputting what I think it's outputting? My custom expression, which cannot... It can actually output a float 3, but then we would lose the scale. I guess it's fine the way it is. The problem is that, is it returning best? Is it not returning anything? No, it's returning best. I don't understand why... The only thing I can think of is that it is returning a 0, 0, 0 or something. So if we take a look, the first sphere is that one up there. Let's see whether or not it's being... No, it's not. Oh, wait, it is. See that? It is darkening a little teeny bit. So really what we're seeing here is simply that the point is inside the sphere because the sphere is quite large. So if we turn off the mesh renderer, you can see it a little bit more clearly. There's a black spot. So really the value problem here is that it's always being judged. It's either going to default to that sphere all the time or it's just not quite right. Let's do a rescale on that and see how it looks once it's rescaled. All right, so now I've done a remap, and you can clearly see that it's definitely being affected. We're going to go ahead and tell that to do its job again. Let's turn that sphere back on. I mean, it's a little bit egregious how obvious these spheres are. We can deal with that later, though. It's just for testing purposes. Now we're going to see whether or not it will be attracted properly to... Yeah, okay, so it is actually calculating distance properly. It's not... There's no problems. There's no problems at all. It's working fine. It's just that my ranges were really bad. So what we've got now is the idea that we're going to be moving towards the closest position if the closest position is within range. So what we actually need to do is the distance to closest needs to be modified so that if our distance is above a certain amount, it doesn't count. What that really means is that we are simply going to subtract the distance from something, like say 5, and then that should mean that if we're very close to it, we'll have a value that's very high, like 5, and as it falls away, we'll fall towards 0. So that's what we're going to try. It should be pretty straightforward. Here is the local vertex offset, and this is the problem here. We're getting a local vertex offset. Ideally, we would use a global vertex offset. I don't know whether or not that's an option I can flip. Vertex output, absolute. There we are. What? That's no good. So I can't give it a world offset. I can either give it a local offset or a local absolute. Obviously, a local absolute would be a nightmare, or it would just be annoying. So we are going to have to translate the position into local. Currently, the position is in global. So we're going to want to change it into local right here before we even register it. So that's going to be world to local. There it is, world to object. Just pow. Is that right? I don't like how it's not transforms input into object space. Yeah, that's right. I don't like how there's no tooltip. It's something that should just have a tooltip, but that's okay. So now we've got this world to object set up, and that means that we should be able to get that position in local space. We could also do that down here if we wanted to get distance and local distance as well. We're not going to worry about that at the moment. But because we're getting that in local space, down here what we can do, we can get the distance and set that up to be a delta. So is delta and a delta time, I guess it's just a subtract. Yeah. So we're going to get the local, well, yeah, the local position. I believe that the local position, I think this is the only way to get it easily. And then we're going to want to grab since this is a vertex situation, the local position of the other points, like on the tries, on the surface, aren't important because they're not the things that are moving at the moment. And then we're going to grab that value that we want. What the heck? Is it G? G. That's going to be the closest here. And if we get the delta, so we just subtract them, and then what we should get is like a really suckered, like it should just like straight into the point that we're looking to. Yeah, see, it's gone. The only question is whether or not it exploded out or it properly went in, and I think it properly went in, but we can't see it because it's all just one point. So what we're going to want to do is just multiply that by 0.5 for a second so that we can just see it a little bit better. No, I can't see it. If this is actually at 0, 0, 0, I'm going to be super angry. I don't see any sign of it actually being at 0, 0, 0. Why can't I see it? It's not, it should be either going towards or away from these points, and that should be something that is like super obvious. I don't see it at all. That's interesting. We'll have to do some testing here. So it may be that my subtract is in the wrong order. I think it is. Yeah, it is. But that shouldn't have made it like vanish. That should have just made it explode away from. But there's a couple more things we have to worry about. One of those things is going to be our value. We are using green, so we're going to grab the vertex color, and we're going to multiply that by the green here. Because that is our setup. So you can see how it's not going the right direction. It is flying off into the sky. I see the problem. We couldn't see it because it's erroring on the setup there. That's fine. We'll deal with that. So what we're going to do now is why is this erroring? This should be correct. All right, I don't know what's going on here, but we're going to need to find the value for our range. There's our range. So we're going to go ahead and fetch that, get that local value, and we're going to just run it through the ringer a little bit. Distance to closest. We could either remap it or we could just subtract it. I think remapping it is probably a little bit better for us at this point. So if we put that in, it's going to be a value between 0 and, say, 3. We'll change that value later. We're going to make that go the opposite direction. It's going to be between 1 and 0. And then we're going to do a clamp. And then we're going to drop that in as our fourth value here. And this, we're just going to have sucker aggression. There. All right, so you can see that it is now substantially less wrong, but it's still very, very wrong. There's just something goofy going on here. I'm not really sure why it's doing this. So you can see that it actually kind of sweeps away from the target, but it sweeps away from the target in a really strange direction that's 90 degrees off of what it should be doing. Now my assumption is that my attempt to move things into local positions has failed. Because that is clearly being attracted to something that is nowhere near where we're trying to get to. This does take in the world component and spit out a local position. The vertex position should be local as well. Yeah. So this must be the part that's malfunctioning. But all I can think of is that it's not actually in local space, and I've screwed up something about that. So this might be one of those undocumented issues where it's not actually in local space or something. Let's go ahead and get rid of the world object for a second. And this vertex position, we can replace that with world position. And now we have the world position offset. Now this should be something where we should be able to see it line up if we are unrotated. Let's find out. So I've just gone ahead and switched everything over to world position. And we're going to go ahead and boop, and try it. Okay. So it's definitely going the wrong direction. It's moving away from it rather than towards it. So I think we're just going to flip that around. But the thing is, this is rotated. It's rotated 90 degrees. So this shouldn't be correct. This should be... Well, I guess it is incorrect. It's definitely not quite right. So if we take a look at the game object, it's rotated 0, 0, 0, and it's a root object. If we then take this and we rotate it 0, 0, 0, in theory, this should be either correct or 100% opposite. And it looks like it's 100% opposite. Let's go ahead and unreverse things to see whether or not it is properly lined up. And we'll scale this down a little bit. Now we'll leave it like that for now. And the idea here is that if we were going to move the sucker, see that? So now what we've got is a method to try and suck towards these. See? Oop, oop. Now, obviously, it's a little bit wonky still, so we're going to have to work on that. This is the basic idea. The problem, of course, being that if we rotate this 90 degrees, or however many degrees, could you please grab the one I'm trying to grab? Thank you. It doesn't really work because it's all in world space instead of local space. But that's not a big deal. We should be able to translate that vector. Cookie says, cool. Hello. We should be able to translate that vector. So we're going to delete some of these extras that we don't need anymore. Then we're going to do a world to local want a world to object, but it needs to be a direction. Transform direction. Yeah, here we are. From world to object. Boom. Oh, and we need to normalize it, don't we? No. No? I don't know. We might try normalizing it later. All right, so there you can see that now that it's in local space, it's a little bit better lined up, trying to, ooh. Okay, so that's definitely a little screwy when you go, ooh. It's a little bit screwy when you are too close to too many different squid targets, but that should be fine. We'll figure out a way to deal with it. So in theory, it should go shboop. No, it's not. It's not going shbloop. See, it's getting the shape correct, but it's not really going towards the target enough. Even at the sucker aggression of 1, it should be moving towards the target really, really aggressively. And instead it's just moving, well, I guess it is. Okay, so I think what's going on here is that the fall off is really pretty aggressive. That's something we should probably be able to adjust anyway. So we're going to go ahead and create some floats for that. Cookie is posting pictures of people. I think that's probably a hello emoji. So this is going to be min range. Duplicate that, max range. So what we should be able to do at this point is these should be something where we can adjust these values so that they're much more attracted to the target rather than skewing, but they still skew pretty bad, don't they? So there are a couple of things left for us to do. Right now we are being attracted to a target without bothering to check whether or not it's on our normal. So basically what we want to do is we want to reduce the amount of attraction we get based on how far off of our normal it is. But the problem is that our normal is not actually set up because the sides here have a different normal than the face. So what we actually need to do is use the object position, the object forward vector. In this case, I don't believe that the object forward vector is actually the forward vector we want. It looks like it is the object up vector or the down vector perhaps that we want. So what we're going to need to do is take a dot product between the local, in local space. That would work, yeah. So here we've got the local space direction. Let's go ahead and register that. Local space delta. So once we have the local space delta, what we can do is, I should probably put that up here. Delete that. There you are. So now that we've got the local space delta, all we need to do is calculate out the dot product of the local space delta and a vector of our choosing. So to keep this flexible, we're going to use a vector 3. And we're going to go ahead and call this object forward. And so when we do that, we can just take a dot product between that and the local space delta. But we probably want to normalize the local space delta. So we'll just put in a normalized value. And that's going to be yet another thing to multiply by. So the thing is, we're probably going to want to modify it. I guess it's probably fine as is for now. We'll just drop that in. See how it looks. Now, unless I miss my guess, we probably have the wrong object forward value. We'll find out in a minute here. So we didn't clamp it. That's a problem. So let's put in a clamp, meaning that it can be negative. And that's what you're seeing here, is it's backwards. It's negative. So we're just going to drop in a clamp so it can't be negative. And we will just invert the dot product, or just invert the normal. Yeah, so that's a -1 instead of a 1. There we are. And we'll just hit recompile. There we go. So now what we've got is a setup where if we're dead on, it should be relatively strongly attracted. Whoop. Like that. But the more off of center we get, the less it's going to work. Now, I just don't understand what's this. Why is it doing this? Because the vector between the edge of the tentacle arm here and that, I guess it's 0.45. So really, the issue here is that we need to have a much smaller squid tentacle and a much larger effect here, I guess. I'm trying to figure out the best way to do this, and I'm not really having too much luck. See, what I'd like it to do is actually move that way, just like sweep its entire vector that way. But instead what I'm getting is a very, very strong attraction on the leading edge, which is absolutely not what I want. So I guess the first thing to do would be to change this out for a normal. And that's made it even worse. Okay, so I think that the reason the leading edge is so bad right now is because the dot product between this point here and the center is about 0.45 or 0.5. But the dot product between this edge over here and the center is like 0.3, 0.2. It's much less aggressive. So I think we're going to go ahead and detangle the dot product for a second. Yeah. But we still have this problem where the leading edge is so aggressive. I really don't want that. I just don't know how to get rid of it. I want the entirety of this tentacle to either be moving towards the target or not moving towards the target. And I mean, I could put in a sharp cliff, but I don't want to, because then it would be like a sudden snap. What if we were to change this to like 1.5? See, it's not working because the radius of the effect is so much smaller than the tentacle. So if I were to change it so that the squid sucker was quite small in comparison to the range of effect, it's barely noticeable. All right. Still kind of noticeable, though. So if we were to hide this guy so that we can get a little bit closer and see how it works. Ooh, it actually implodes. That's fun. So my guess is that at this point, what we're seeing is I don't think that's going to be an issue, but it's obviously a little bit silly. Still, it's fine. We're not seeing nearly as much side-to-side movement as I'd like. I'll have to think about it. Great. So I wasted your time, everybody, with 2 hours of work on this. Hopefully you've enjoyed seeing how game dev works, because that is sometimes how it goes. I'm going to stop now because I'm starving, and I'm going to eat this microphone if I have to keep talking at it. So thank you for keeping me company, and I'll see you on Wednesday, maybe a little earlier. Bye.